Alright, for this video, we will continue for the third element, which is we will cover simply supported beam and also the continuous beam. Okay, for the design parameters, first of all, the FCK that we will choose is 25 Newton per millimeter squared. Also for FYK, 500 Newton per millimeter squared. For the unit weight of concrete, we will use a 25 kilonewton per meter cube. For exposure class, we will use a XC1. For the standard fire resistant, RE1, REI60, and also the design life for 50 years. And then the last one, concrete grade 25. Concrete grade is 25. Okay, this is calculation of the critical simply supported beam. Okay. Okay, at the top of the calculation, I have provided the illustration of the critical simply supported beam, which is besides it has slabs that we will transfer the self weight of slab, load the distribution of slab to the beam. Okay, then we will go to the conclusion. For the preliminary size, we will use the size brick wall 150 millimeter, and then plaster thickness 20 millimeter, wall thickness 135 millimeter, and then we will consider the size of the beam is 150 millimeter, more than the wall thickness. Okay, and then for the H, we will use a rule of thumb, which is 3 times 1 over 3 H, and then we get 450 for the H, and then the dimension of beam is 150 millimeter times with 550 millimeter 450 millimeter. Then for the design load W, we will use a formula 1.35. We will times with self weight of slab, finishes, brick wall, plaster, and beam. We will plus with 1.5 QK. And then the critical beam is beam 5B A1. And then we will calculate the area of the slab. Then for the slab A, we will get 1.89 meter squared, and also for the slab B, we get 2.25 meter squared. And then for the self weight of slab, we get a 5.3 kilonewton per meter, and then self weight of finishes ceramic tiles, we get a 1.42 kilonewton per meter. And then we calculate the self weight of brick wall, 7.73 kilonewton per meter, and then also the self weight of plaster, 0.78 kilonewton per meter. And then for the self weight of slab, we will use 25 kilonewton per meter cube times B times H, and then we get 1.68 kilonewton per meter. And then for the total GK, we got 16.91 kilonewton per meter, and then for the QK, we got 2.83 kilonewton per meter. For the design load, we will use for the design load N, we will use formula 1.35 GK plus 1.5 QK, and then we get 27.07 kilonewton per meter. And then for bending moment and shear force Vmax, we will use formula WL over 2, and then we got 40.61 kilonewton. And then for moment max, we will use formula WL squared over 8, and then we get 30.45 kilonewton meter. And then this is the bending moment diagram and also shear force diagram that I have provided in this calculation. And then we will go through for the next calculation. Okay, for the nominal cover C norm, we calculate, we get a 29, and then we will consider to use 30 millimeter. And then for the effective depth, uh, we will calculate the effective depth, and we get a 404 millimeter. And then for the D prime, we get 46 millimeter. And then for the manual enforcement design, SWIN, we calculate and we get 7.8.78 millimeter squared per meter. And then also as max 0.04 C for AC, and then we get as 2700 millimeter squared over meter. And then we calculate K, and we got the value of 0.049, which is less than K balance 0.167, and then we will use that value. And then we calculate the Z, we get 0.96 D, and then we calculate the AS required, and then we get 182.39 millimeter squared over meter. And then the AS provided, we choose 2H12, which is the value is 226 millimeter squared over meter. For the shear reinforcement design, VED, we choose VED is equal to Vmax. So we take the value of Vmax 40.61 kilonewton, and then so we should calculate the VRDC. For VRDC, before we calculate the VRDC, we must calculate the value of K, which is we get a 1.7, and then we must calculate the value of rho 1, and then we get a 0.0037, and then we calculate the VRDC. We get the VRDC. We get the VRDC 55.9 kilonewton, which is more than Vmin. So Vmin, we calculate 23.5. So the VRDC value is 55.9 kilonewton. So minimum shear reinforcement is required. So VRDC is equal to 55.9, which is more than VED. So for maximum link spacing, we calculate S max, and also then we will calculate the shear link areas, and then we got to use H8 300. Then for deflection check, we check only at midspan with max moment, and then we will use the AS required before this at the previous, and then we times it, as required, we divide by the B times D, and then we get the value of rho 0.0030. And then for the reference reinforcement ratio, rho naught, then we get 0.005, which is rho naught is more than rho. So factor for structural system is 1. And then we calculate the LD allowable, we get 32.2, and then we calculate the LD allowable, and then at LD actual we get a 7.43, which is less than LD allowable, so the beam is safe against deflection. For the crack check, we must calculate S, which is we get 50 millimeter, and then the FS we get 285.20 MPa. We taking WK is 0.4 millimeter, so maximum allowable clear spacing is 150 millimeter, which is more than S. So the crack check is passed. So this is for the detailing. The section AA is cutting section. then the beam dimension is 450 millimeter times 150 millimeter. And then in the beam we will use 2H12, and also for the shearing we will use H8 300. Then we will calculate the taking off for simply supported beam. For simply supported beam, we will taking off formwork. We get 1.2 meter squared for inner, and then soffit 0.45 millimeter squared. Okay, and then we taking off a reinforcement. We get the value 6.444 meter. And then for concrete, we taking off, and then we got a value of 0.1923 meter cube. And then for link, we got a value quantity of 2.4 meter. And then this is the build off quantities of simply supported beam. So for the concrete G25, the quantity that we get before this is 0.1923 unit is in meter cube, and then the latest rate of the concrete G25 is 189, and then the price of the simply supported beam for concrete is RM 36.34. And then for the reinforcement, we have two types of reinforcement, which is H12 and also H8, which is the rates of these two reinforcement is still the same in the market. And then for the H12, the quantity is 11.44 unit in kg, and also the price is 26.07. Then for H8, the quantity is 0.95 kg, and then we get the price is 2.16 RM 2.16. And then for the formwork, we will use 6mm thick plywood 4 times 8 first grade. The quantity is 1.65 unit is in a meter squared. The latest rate of the formwork is 10.01 RM 10.01. And then for the price of the formwork that we will use in simply supported beam is RM 60.52, and then for the total bill is RM 81.1 RM 81.10 cent. That is for the simply supported beam. And then we will go through for the critical continuous beam, which is we consider the critical continuous beam is the most of the beam that have the maximum value of length in the house building. Okay, for at the top of the calculation, I have provide the illustration of the critical continuous beam, which is besides it have a slab that that transfer the load to the beam. So for the preliminary design, LD is equal to 30. So the longest span is 6 meter. So the D is 0.2. For H, we got a 248. And then for B, we got 1/3H. So B is 82.67 millimeter. So we consider the dimension of the beam is 150 millimeter times 450 millimeter. For the design load, we will use the same formula like simply supported beam, which is 1.35 GK plus 1.5 QK. And then self weight of brick wall, we will use self weight of brick wall we will use at 7.73 kilonewton, and then self weight of plaster 0.78 kilonewton per meter, and then self weight of beam is 2 kilonewton per meter, and then this is the calculation for the self weight of each beam, and we will start from the beam C2 to A until the last beam, which is C78, and then area of slab first. Area of slab A is value is 2.25 meter squared, and also area of slab B 1.35 meter squared. And then for the self weight of slab is 4.5 kilonewton per meter. And then self weight of finishes ceramic tiles is 1.2, and then the total GK we get 16.21 kilonewton per meter, and then QK 1.5, and then we calculate the design load, and we got 24.58 kilonewton per meter. And then for beam C to A4, we calculate same like the previous beam, and then we get the design load is 32.64 kilonewton per meter. And then for beam C45, we calculation is also the same, and then we got the design load is 27.12 kilonewton per meter. And then for beam C 56, we calculate, and then we get 30.47 kilonewton per meter. So for beam C 67, we got 43.5 kilonewton per meter for design load. And then for the last beam in the continuous beam is a C78, and then we calculate that, and then we got 44.28 kilonewton per meter for the design load. And then we calculate the bending moment and shear force, and then in the bending moment and shear force for the continuous beam, we must calculate the stiffness factor, the distribution factor, and then for the value of fixed end moment to do the moment distribution method. Okay, and then for this is for the fixed end moment, and then this is the distribution table that I have calculated all the member, and then we got the final moment, which is for A we got a 14.74, for B we got moment 85.47, and then for moment C we got 77.67, and then for point D we got 22.46, and then for joint E we got 47.55, and then for point F we got 29.25, and then for the G we got a 36. And then we must calculate the support reaction at all segments in the continuous beam. We have a segment AB, BC, CD, DE, EF, and also FG. After we calculate the reaction, we must provide the BMD and SFT, which is bending moment diagram and also shear force diagram. Okay, this is my SFD and BMD for the continuous beam. Okay, then we proceed on the next calculation for analyzing the design continuous beam. Okay, for the nominal cover, we will use 30 millimeter, and then for effective depth it is also 404 millimeter, and the many reinforcement design beam, as mean we get a 78.78 millimeter square per meter, and then for AS max 2700 millimeter square per meter. So maximum moment at support, we considering 85.8 kilonewton per meter as the maximum moment, and then we will calculate the K value, and then we got a 0.14, which is less than K balance 0.167. So the compression reinforcement is not required to design. Okay, so then we calculate the Z value. We got a 0.88 D, so we will use 0.95 D. And also for AS required, we calculate and we got 554.80 millimeter squared per meter. So AS provided is 2H20 628 millimeter squared per meter. So the AS mean is less than AS provided. So AS provided is less than AS max. It is okay. And then for the design shear reinforcement, so VED is equal to Vmax. So it is equal to 99.05 kilonewton. Okay, and then we must calculate the VRDC. And then before that, we must calculate the K value and also rho 1. For the K value, we will use 1.7, and also rho 1, we will use 0.01. So we will calculate the VRDC value, and then we got a 36.148 kilonewton. It is more than V mean. So VRDC is 36.148 kilonewton. So VRDC is equal to is less than VED. It is okay. So the shear reinforcement is required. So we will calculate the shear reinforcement, and then we got the value 170 kilonewton, VRDC max 22, and then we will determine the shear link spacing as it is equal to 300 millimeter. So we will calculate the maximum link spacing. We will use H8 300. Then we will go through for the deflection check, and then we will check only at midspan with max moment. So for rho, as required over BD, so rho is equal to 554.8 divided by 150 times 404. We will get the value 0.009. So calculate the we will calculate the rho naught. Calculate the rho naught, and then we will get the value 0.005. And then factor for structural system K, it is equal to 1.5. And then modification factor for steel are provided. We will use 1.13. So LD allowable, we calculate, we got 25.7. So LD actual, we got 14.85, which is the value is less than LD allowable. So beam is safe against the deflection. So for the crack check, we will check only at midspan with max spacing. So we will calculate the S. So we get 50 millimeter, and then we calculate the F as value. We got 282.51 MPa, and then we taking WK is 0.4 millimeter, and then maximum allowable clear spacing is 150 millimeter. It is more than S. It is okay. So crack check is pass. Okay, this is for the detailing of the continuous beam. Okay, the dimension of the beam is 450 millimeter times the time with 150 millimeter. So our continuous beam have a six segment. which is at first we have a 3 meter, and then second 6 meter, third one 3 meter, then 4.2 meter, and then 3 meter, and also the last one is 3 meter. Okay, so in this detailing we will use a value of the reinforcement to H12, and then we will use value of the shear is H8 300. So for the taking off the continuous beam, for formwork, we calculate for all the segment of the continuous beam, and then we get all the value of the formwork that we will use in all the continuous beam segment. Okay, for the reinforcement, we will calculate also for all the segment. We will get the 12.888 meter for beam C A2, and then beam C2A4 we get 24.888 meter, and then C45 we get 12.888 meter, and then for beam C23 we get 18.168 meter, also 12.888 meter for C45, and then the last one beam C4, the last one is 12.888 meter. And then for the concrete, we calculate all the concrete, and then we will sum up at the bill of quantities in the next slide. And then for the link, we get the total value is 14.4 meter, and then this is a bill of quantities of continuous beam. Bill of quantities of continuous beam, first we have a concrete grade 25, and then the quantity of all beam, all the segment that use is 1.436 unit in meter cube, and the latest rate is 189, and then the price of the continuous beam is 271.4. And then for the reinforcement we will use H12 and also H8. Then the quantity of H12 is 83.94 unit in kg. The latest rate of the reinforcement H12 is 2.28, which is the price of the reinforcement is 191.339. And also for the H8, the quantity is 5.68 kg. The latest rate is also the same, and then the price that we will use is 12 ringgit. And then the last one for formwork, we will use 6mm thickness plywood 4 times 8 first grade, and then quantity that we will use is 12.21 meter squared, and also the latest rate is RM 10.01, and then we will get the price that we will use is 122.22 cent. Then the total bill of this continuous beam is RM 597.96 cent. Alright, that's all for the explanation for the simply supported beam and also the continuous beam. It is a long journey to do all the things like calculation, and then we must prepare the bill of quantities of all the element. So I hope that uh, uh, we will, I have I hope that I can understand more about the civil and engineering experience, and then I hope that I can get the good marks in this subject. Okay, I think that's all for the explanation for all the three elements that needs to be present. That's all from me. Thank you.